In the previous video, we learned about I/O structure. In this video, we will see this in practice. I/O is a structure that represents computation. This computation is modeled by function, and this function is not depending on any inputs and always returns a value of some type A. I/O is great for modeling computations that have side effects, which do not error out. Let's see what kind of operations we can do on I/O structure. But before that, let's add the imports we need. Import hkt kind from. If this looks new to you, I have a dedicated video on kind and higher kind of types in this course. We need compose and maybe compose R. If this again looks new to you, I have a dedicated video on function composition. And also we need Functor 1. And I have a dedicated video on functors too. Lib functor. From the type class demo video, we already know we need to add some boilerplate code to introduce I/O as a structure so we can define operations and type classes for it. Again, if this looks new to you, please check out my video on type class demo in this course. Let's define our first operation and type class for I/O, which is functor. Since I/O is a functor, we can define a map function for it that by receiving a function from A to B, it can leave that to a function from I/O of A to I/O of B. I/O_B can be calculated by first calling I/O_A, pass it to F, and finally we can wrap this in a func function. And let's not forget adding URI, which is a boilerplate that we need to add to make this work with FVTS and TypeScript in general. If you take a look at this part, this should be pretty familiar. This is a function composition of F and I/O_A. So let's rewrite this using compose. The reason that linter is showing an error here is that when we implemented the compose function, we didn't pay attention to the case of composing a function with no inputs. So let's fix that. In order to do that, let's say generic type A is of type array of any type. And let's rename x to xs and spread this to specify that this is an array. Let's fix the implementation too. Let's do the same thing for compose R2. Of type array of any type. Let's rename this to xs. Also, let's rename this to x. And let's split this xs here. Also in the implementation, say xs. And let's spread xs here too. If we save, let's save and close this. And now we see that the error is gone. Now that we have defined the functor type class for I/O, let's see this in an example. Let's first make some space. Roll dice is a type that represents rolling a dice, which always gives us a number. If we try to assign a value to it, it would look something like this. Roll dice. The first thing we want to do is we want to get a random number, times it to 6 to get the value from 0 to 6. Then we're going to round this to the next number, next integer. And finally, we need to wrap this into a func. Next, let's define a isEven function that first receives a number and returns a boolean. And the way it works is isEven of type isEven receives a number, and we're going to check the remainder of it divided by 2 is equal to 0. Now we want to see if we roll a dice, are we receiving an even number or not? But the issue is isEven is receiving a number, while roll dice is of type IO of number. How can we make this work? Well, using the map function, we can lift isEven to IO context, right? So let's do that. Const IO is even. We're going to use IO functor.map, and we're going to pass isEven to it. Now, if we look at the type IO is even, we see that it receives an IO of number and returns an IO of boolean. This means that we can now pass roll dice to this function. Let's do that. If we look at the results, the type of it is IO of boolean. Now let's say we want to log this boolean value on the console. How can we do that? The issue is that this boolean is wrapped in IO. How can we make console log get access to this boolean value? Well, the same way we did with isEven function. We need to lift console log to IO. So let's do that. Const IO console log IO functor dot map console.log. And now we can pass result to IO console log result. And let's name this our program. To make this easier, let's make this in line. Let me cut this part and let's put this inside result, and let's get rid of this part. If you look at the type of program, is now IO of void because console log returns void. All right, we are ready to test our program. Let's run this, for example, 3 times because we have a random. We are using a random value. If I save, we get, for example, true, false, false on the screen. If I save it again, we get a different values, false, true, false. This is great. As you can see, our program is completely functional. We delayed all the side effects like getting a random number and logging to console all the way to when we actually invoke and run our program. It means we are completely in control in every aspect of our code. And with that, thank you for watching this video. Please like and subscribe, and I will see you in the next one.